Lesson number 56 is about finite and infinite sets, membership in a set, and rearranging before graphing. So the definitions that we have in this lesson are a finite set and an infinite set. A finite set just has an exact number of numbers. A set is always shown within our braces. And here we have an exact set of numbers, 1, 2, 3, and 4. An infinite set just has an unlimited set or unlimited number of numbers. So we have 1, 2, 3, 4, but dot, 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 that means our pattern continues. So we'd have 5, 6, 7, 8, 9, 10, 11, 12. We keep on going and going and going. So we have an unlimited set or unlimited number of numbers, and that's called an infinite set. Let's look at a couple examples. Here we want to represent the following numbers as being members of set K. So if we have set K, the way we're going to write that is, well, we have set K. So K is going to equal, and then within our braces, has to be a brace for a set, we're going to have our numbers. And when we write out our numbers, we can write them numerically or not. It doesn't make a difference. But writing them numerically helps us to identify any patterns that we have. So we've got 0 and 0. We've got 1 and 1. We've got 2, 4, 5 and 5, and 7 and 7. Now this is obviously a finite set, and it's a finite set because it has a limited amount of numbers, or a certain number of numbers. There's no dot, 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 the ellipsis on either side that mean our pattern would continue. Let's look at another problem. Given the sets here, we have L is equal to 0, 1, 2, and 3, M is equal to 5, 6, and 7, and N is equal to 0 and 1. Are the following statements true or false? Now we have some new symbols here. What this is saying is 6 is a member of set L. And we wrote it out here for you so you know what this symbol means. It just means is a member, is part of that set. So we're asking, is 6 part of set L? Well, no way, because L is only 1, 2, and 3. So our first question, 6 is a member of L, that's false. Then 0 is not a member of set N, and we can hear it, we can see it written out right here. So this symbol means not a member. So 0 is not a member of set N. Well, 0 is a member of set N, so we've got 0 and 1. So this statement, it's also false. We just need to know that these symbols means is a member of the set, and this one means is not a member of the set because it's crossed through. Let's look at our next problem. Now this is about rearranging before graphing, the second part of our lesson. And what we want to do when we rearrange before graphing is to set y equal to everything else. So in order to do that, we're going to have to subtract 3x. And let's move our number up a little bit so we have some room to work here. So we're going to subtract 3x from both sides because we want to get y by itself. So we're going to subtract 3x. We're going to be left with 2y is equal to 4 minus 3x. And then in order to get y by itself, we know that we're going to have to divide both sides by 2. 2 divided by 2 is 1. Divide by 2. Divide by 2. So now we're going to get our simplified problem. We get y is equal to 4 over 2, that's 2, minus 3 halves x. Now what we want to do in order to graph is to build our xy table of values. And this is a linear function, so we're going to have at least 2 points. Let's pick our easiest point for x first. If x is 0, then we're going to get y is equal to 2 minus 3 halves times 0. Well, 3 halves times 0, that's 0. That's why we like that one. So y is equal to 2. When x is 0, y is 2. And we'll plot that in light blue today. X is 0, y is 2. Now let's pick another one. Let's pick a value of, well, for instance today we'll pick 5 for x. So we'll say y is equal to 2 minus 3 halves times, we're going to say 5 over 1 because that's the same thing and we're working with fractions. So when we go ahead and solve this, we're going to need some more room. We'll work at the bottom. So we're going to get 2 minus 3 halves times 5 over 1. Multiplication comes first, so we're going to get 15 over 2, 15 over 2, and 2 minus 15 over 2. Now 15 over 2 is the same thing as 7 and a half, so we're going to get 2 minus 7 and 1/2. Well, 2 minus 7 and 1/2, that must be equal to negative 5 and 1/2. So, when x is 5, y must be equal to negative 5 and 1/2. And we can graph that. We can graph halves just as easily as we can graph wholes. So, x is 5, right here. Okay, we're going to erase that dot though. So, x is 5, and y is negative 5 and 1/2. The half will just go halfway between negative 5 and negative 6 on our scale. And then we've got 2 points. Remember, this is negative 1, 2, 3, 4, 5, and 6. So this is negative 5 and 1/2 on the y and positive 5 on the x. Now all we need to do is make a straight line between those points, and we'll be all done with this question. So we've got our straight line running right through our blue points. All we need are our arrowheads. And we're all done with this question. We've graphed 3x plus 2y is equal to 4 by rearranging before grouping, then building our table of x and y values, and plotting our points, and then connecting a line through those points. We've got one more problem today. We want to graph y minus x equals 0. Now this is a nice one because when we solve for y, we're going to add x to both sides. So we only have one step. And what we get is y is equal to 0 plus x. So that just means y is equal to x. So if we build our table of values, x and y, let's make x equal to 0 because we always want to solve that one. If x is equal to 0, well, y is equal to x, y must be equal to 0. If x is equal to 2, then y must be equal to 2, because they're always the same value, since they're equal to each other. So we can plot those 2 points, 0, 0 on the origin, and 2, 2. 2 on the x, 2 on the y. Well, we've got enough points to graph now, we just need a straight edge. So, we use a straight edge, and we'll go right through those points just as accurately as we can, all the way through. That looks good. This is a line, so we've got to put our heads of the arrows on there. And we're all done. We've graphed y is equal to x. Our lesson practice will be on page 231. Make sure you've got your notes complete, and I'll see you during our next class.